Yeah, first step, we have to write the equation for all the state. So here we are having two state Q0 and Q1. First I simply write for initial state Q0. Okay. So while writing the equation, we need to check the transition for in degree. In degree means towards the state. For example, Q naught of A towards the Q naught. Okay, so this transition Q naught B means it is outwards. Okay, so first find the in degree of the transitions. So first you have to write the equations Q naught of A because in degree. Okay, then initial state you have to add always epsilon. You just give the numbering 1. Okay, while writing the equation itself, you have to check whether the equations like this. Okay, which one is R, which one is Q, which one is R plus P. Okay, so now you check. So definitely this may be R equal to, this is R, this is P, this is Q. We are going to convert R is equal to Q P star. So what is the final equations? Q is equal to epsilon. Q is here epsilon. What is P now? A star. A star. So epsilon with A star, we are getting A star. Okay. So we need to check, otherwise we need to map these equations like this. Okay. Yeah. So next find the equation for Q1. So what is a Q1? Q1 means we are getting Q naught B because in degree. Okay, Q naught B. So now Q1 is a final state also. So we need to find the equations final state always. Okay. For example, Q1, what is the answer for Q naught? Q naught. So now we are having the equation Q naught. So you know this value of Q naught, A star V. Okay. So this is your final regular expressions for this. Because here Q1 is a final state. So in figure itself we can identify what is the regular expressions, A star B only. But anyway, as per Arden's theorem, we have to solve and get the result. Okay. So this is a way of solving this using Arden's theorem. First we have to form the equations Q0 and Q1. While forming the equation, we have to ensure any equation like this in this format. If you are having this equation in this format, we can check P does not derive the epsilon. Does not derive the epsilon, you can make it R is equal to Q P star. While writing the equation, you have to just map this, what is R, what is P, what is Q. So based on that, we can simplify the regular expressions. So this is a final solution for this finite automata into regular expressions. So this is another problem. We are going to convert automata into regular expressions. Problem number 2. Yeah, initial state as well as final state Q1 and Q2 then it start with A, here also B, then A, then Q4, Q3, traverse with B, and A, then B. So this is given automata. So we are going to find the equation first. After that we can check is it possible to apply the Adam's theorem and reduce the equation. Okay. So what is the equation for Q1? Initial state is Q1, here final state also Q1, but anyway we have to write the equation for all the states, then only we can find the regular expressions accurately. Yeah, first you have to write the equation for Q1. What is Q1? In degree you have to check. Okay, so in degree here Q2B. So Q2B, any other? Here Q2B, here also Q3A. Q3A plus, so no possibilities apart from this is outward. This is outward, so you just add this epsilon, you have to give the numbering 1. This is the equation number 1. So equation 2 like that you have to check. So what is Q2, Q1A, Q1A plus Q2, any in degree, nothing is here. So you just leave it. The equation is 2. Okay. So like that you can write the Q3 equation also. Q3 you are getting Q1B only. Q1B. So this is your third equations. So next one is Q4 you have to write. Yes. Q4 means Q2A plus Q4A, because Q2A then Q4B, Q2A then Q4A plus Q4B plus Q3B. Yeah, so this is fourth equation. Yes. Now you ensure is it possible to reduce, apply the Adam's theorem. You have to check is in any format of this equation. Among the equation you have to ensure any equation satisfy the condition of satisfies the theorem of Adams. Okay, so no one, so we have to replace, we have to simplify it after that only. So here finally how to take the final state. We'll start with final state also. Is it possible? You have to apply and replace, then you have to ensure whether it is in the form of Adam's theorem or not. Otherwise you have to substitute. You can substitute 2 and 3 in 1 and 3 also in 1 and 4 also 1. So what are the possibilities where we can check, then after that we have to convert. Okay. So I am simply taking Q1 because it is a final state. Now you are getting the value of Q2 and Q3. You can apply here 1 also. Okay, I am simply taking Q1. Yeah. Q2 value you know, that is Q1A, then B plus Q3. Q3 you are having Q1B, then A plus epsilon. Okay. So you can simplify again. Q1 of AB plus BA plus epsilon. Okay. Q1. Now you ensure that is in the form of R is equal to Q plus RP, then R is equal to Q P star. Okay, so now you check. So it may be this is R, this is R, this is P. You just map it. This is Q. So how it will convert? Q1 is equal to, what is Q here? Epsilon. What is P? P is AB plus PA. AB plus BA star. So epsilon with anything, concatenating with anything, you are getting only AB plus BA whole star. Yeah, so this is your final regular expression for Q1. Because Q1 is a final state, you check in figure itself or automation itself. Yeah, A, B. We are having the path A, B. This is one path. Okay. Again, you are having the path start with B, then end with A. Start with B and end with B. Okay. Start with B, then end with A. So we are having the two path. Okay. Either A, B or B, A. So finally, we are getting the regular expressions like that. So this is a way of converting from finite automata into regular expression through Arden's theorem. Thank you.